is actually day 2 of 12.1. And we're still talking about inverse variation equations. And right now, we're going to write equations. Today's writing. Yesterday was graphing. Today's writing equations. So if x and y vary inversely, when y equals 2 when x equals -6. So write an equation relating x and y. Okay, so when you see this word, or these two, in the same sentence, varying inversely, then you might want to write the model for inverse variation. And it is y equals some constant of variation, right, over the input. Okay? And we know that when x is -6, y equals 2. So what will we do with that information? Plug it in, right? Just plug in -6 and 2. And we did this with direct variation, but that was a long time ago. If 2 equals a over -6, then we're going to multiply both sides. Yep. And a equals -12. Now, we haven't written the equation, and this is something that took place with direct variation too. You have the constant, now go write the equation, right? And the equation is, let's say it, y equals over x, okay? So whenever you're told that two values vary inversely, you've got to start with this. You know that that's the model equation, and just find your constant. Just plug it in, that's it. Okay, so let's try one more. What about if y is 8 when x is -6? I'm going to pause, come back and check your equation. Okay, so if we found this equation here, what we're really being asked here, what is the value of y then when x is 8? Okay, so we use the equation we found, and we say y will equal -12 over 8. And now we simplify, and we have y equals 1.5. Okay, -3/2. Okay, so we received the equation, the information to create the equation here. We wrote the equation, and then we use it to find another value for y given a different x. Okay, we'll try it again here. This is the same sort of thing. You don't need to write this whole sentence down. It's on page 767. It says the variables x and y vary inversely. So right there, when you see that, you go, oh, this is one of these, right? Y equals -2 when x equals 12. So write an inverse variation equation and then use it to find the value of y when x equals -3. Okay, so who can substitute into this equation now? They're telling you that x and y vary inversely when y is this and x is that. So where does that go? Oscar.
Should equal -2 over equals a over 12.
Good. And so we multiply by 12, and what is a equal to? -24. So now can you give me the equation then?
Yeah, -24. Oh, y equals -24 over -2
over x, right? There's the equation that we got. So now we can do part 2. What is the value of y when x equals -3, right? And we just plug it in. Y equals -24 over -3. So y equals 8. Okay, that's all you have to do. You're going to have a series of questions like that. Write the equation and then find another value given a different x. You may also be given the same kind of question in a word problem. So we're not going to do one now, but when you're looking at a word problem like this, all these words, you got to read it. And it says a theater company plans to hire people to build a stage set. The work time, T, varies inversely. So hopefully you catch that. T varies inversely with the number of people hired. So rather than y varying inversely, it's T varying inversely with the people hired. What do they want for people? P? So there you go. You have the same kind of equation. Now it's a word problem. We're using different variables. Okay? Understand? Look for this varies inversely and then use your model. Y equals A over X. And if you need to use different variables, you do. Okay? Okay, second, recognize and write an inverse variation equation. So recall that when we were looking at linear, quadratic, exponential, rational, we could look at a table of points and you learned the patterns to look for to identify what kind of a equation that is. So when we look at a table of ordered pairs, how do we know it's linear? If the x's are 1, 2, 3, 4, 5, how do you know you're linear with your y values? Remember? Good, constant addition. Okay, so you'd have 2, 4, 6, 8, 10, just constant addition. Who remembers how to find exponential? The exponential pattern in a table. If all your x's are just in order, 1, 2, 3, 4, 5, what is the math of the y values? You remember? Say it? Multiplication, right? Okay, so that's what we're going to find out. What is the pattern you would see in a inverse variation table of points? Okay? Starting here, if y equals a over x, then what does the constant of variation equal? What would we do here to isolate a? Good, you're timesing both sides by x, so I hear you say that, xy. What's that cool throwing thing? Okay. So we look for the constant xy to determine if we have inverse variation. We multiply x times y. We multiply the ordered pair together, and you find that it's the same every single time. It's kind of a cool pattern. Really an easy pattern to look for. So is this table inverse variation? If so, then we're going to write the equation. So I'm going to pause so you can take this down. Okay, so let's see if we have a constant product of x times y. X times y. Let's see. What is 4 times 2? I'm looking right at the middle. 8. What is negative 2 times negative 4? 8. This one's a little bit hard. What is 5 times 16? It is 80, and then you'd have one decimal place, right? So this is 8 as well. 10 times 0.8, 8, and 16 times a half is 8. So the constant is the a, right? That is the constant of variation. So the equation is, the model we know is this. So we just plug in our a, 8 over x. It's that easy. Just multiply x and y together. Okay? Pretty easy, huh?
Yeah.
Do we need to see this more? Okay, so is this also inverse variation? And if it is, write the equation. Okay, so what do you get? Negative 5 times 2? It's negative 10. And how about negative 4? What is 4 times 25? 100. So negative 4 times 2.5 is? Negative 10 again, right? And does that look like it would be 10 as well?
Yeah.
Yep. And negative, right? And this would be 1/2, so negative 10. So can you say the equation with me? Ready? Y equals
x over
No. Good. There you go. Okay, can you guys come back at 1 o'clock? And there's your assignment.